So everyone, welcome to the Adventurers Club of Los Angeles. Thanks for turning out tonight. We've got a great turnout tonight. It's nice to see live faces again, and I think we have a great program for you tonight. I think we always do, but if you're not tuning in on a regular basis, you should be. Even if you just want to listen to it, go to any podcast distributor and you can find our programs and take them on the road with you on the freeway to work. Get some great entertainment and learn something every day. So tonight we have with us Buz Carpenter. Welcome, Buz.
I'm glad to be here.
Okay. We're going to work on your sound. There we go.
Sorry, just say that again, Buz, please.
I'm delighted to be here with you tonight. How's that?
Excellent. Much better. Well, thank you. Thank you very much for tuning in with us, Buz. Buz is on the East Coast, so this is middle of the night for him. And we really appreciate you staying up to help us learn something new tonight. Buz is, amongst other things, an ex-SR-71 pilot, which I think a lot of people in the room think is probably one of the coolest things to ever hit the air. And I'm sure Buz will probably agree, but we'll get his opinion on it. Buz, if you could tell us a little bit about yourself and
Sure.
kind of your prehistory, we'd appreciate it.
Well, I grew up in Oakland, California, and went to the Air Force Academy, graduated with the 9th class. My first flying operations were with C-141s flying worldwide, which was a great experience, going into many different airfields and experiencing many different traffic areas. I had to kind of chuckle with his reminiscence about going into Turkey. Going into Turkey was always an interesting experience. I volunteered to go to Southeast Asia, which opened up a door. I flew RF-4s, which was the camera version of the F-4 in Vietnam and Thailand, and would fly the program for 5 years. But most importantly, one of the bosses I worked for was a Colonel Jerry O'Malley at the time, later 4-star General O'Malley, who flew the first operational mission in SR-71 and basically took me aside and said, you know, you're the kind of guy that we want in the program, but you're way too young because you need over 2,000 hours of flying time. So you had to be a volunteer. You had sent your medical records, your personnel records, and your flight records. They did an evaluation. If they liked you, they brought you back for a week-long, 2-day astronauts physical, bunch of interviews. I had to fly in a T-38 with current SR pilots to see how you handled. Some more interviews, and then I got sent back to Japan because that's where I was flying out of at the time. And about 6 months later, I got a telegram that said, you're coming, you've been selected for the SR program. I flew for 6 years with the program and had over 65 operational missions. Last year and a half, I was an instructor in the program. I went to the Pentagon, and for 2 years, I was like a kid in a candy shop. I had all the Air Force Blackworld programs. I was the programmer for it. So that was the B-2, the F-22, the 117, and programs I still can't talk about. From there, I got checked out at F-4s, had an F-4 squadron, converted to F-16s, went to Europe, was a wing commander in Europe during Desert Storm. And then my last real assignment was coming back to California and being the vice commander of 2nd Air Force. 2nd Air Force had basically all the reconnaissance and surveillance assets that the Air Force had at that time spread around the world. So when I retired, I went to work for industry. And my retirement gig right now is being a docent at the Air and Space Museum in Washington, D.C., and working with 29 other museums that have Blackbirds anywhere. One of them is over in England, but the rest of them are in the States. And I was lucky enough in 2017 to be selected and inducted into the Virginia Aviation Hall of Fame.
Wow, outstanding. Well, we have some club history with SR-71 through Bob Gilliland, who was a member. And,
wonderful. Yeah, what a great guy. We lost a huge, you know, I often, when we do symposiums on the West Coast, I remind people without Bob Gilliland and Pete Law, who did the thermodynamics, none of us would be having these symposia because there wouldn't have been an aircraft.
Well, I want to hear every excruciating detail about the aircraft, but before we get into that, you're also affiliated with the Cold War Museum?
Yes, I am.
Can you tell us a little bit about that?
The Cold War Museum is basically a product of Gary Powers Jr. When his father was killed tragically in that helicopter accident in Los Angeles, he realized he really didn't know a lot about his father's earlier past. And so he spent his life learning about what his father did, but also with Sergei Khrushchev, David Eisenhower and Julie Eisenhower and others, to basically document what happened in the Cold War so that our younger generations won't forget the 40-some years in a very, at times, desperate struggle with the communist Soviet Union. And at one time, there were places in Eastern Europe, which obviously the Cold War had a greater impact on them because they were being basically under Soviet rule. There's a small museum now in Vent Hill, which used to be the code-breaking site from World War II and was active until 1970. We're about to take occupancy on the a Nike site outside of Washington, D.C., and we're going to have an opportunity to really expand what we're going to be able to display and bring a little more realism to our guests that come to the museum. I'm on the foundation board. That's my relationship with the museum.
Well, it was Gary that put us in touch with you, so kudos to him. Thank you, Gary. I think we have a little video we'd like to run first, and then let's talk aircraft.
That sounds good.
Andy?
SR-71 is a combination of power and majesty. When you look at it, it just has a mystique that I think is going to live for generations and generations. I wish I could take everybody up to 85,000 feet because you could see 350 miles in any direction. You see the curvature of the earth, mountains, 10,000-foot mountains look flat. I can say without a question is that people knew that there would be an SR flight, and when they cranked those engines, the Buick Wildcat would scream. Then when the SR engines came on, people from around the base would just kind of stop. 117 decibels, that's what the SR was on takeoff. Six presidents used the SR-71 extensively because they had a great sense of confidence that it could in fact go out, collect the information required, and bring it back. Hundreds of missiles were fired at this airplane. I couldn't tell you how many times fighters came up to intercept me. I remember part of our missions when I was flying in the late 70s was fly through rings of SA-5s. We knew it was a very capable missile system. They weren't concerned too much about the SR, but they were very concerned about others. And they figured we could collect enough information that we could understand how that missile system would work. If we carried the nose camera, which we called the country's camera, it took a picture 72 miles wide. In 64 minutes, you would film 100,000 square miles. The film itself was 10,500 feet long, 5 inches wide. I would say my mission into the Middle East for President Carter was one of the most interesting. It was supposed to be 3 missions, but we picked up all the targets in that first mission that they needed, so the next 2 missions were canceled. The airplane loved to fly straight, climb, and accelerate. Most of the time at altitude, 80 to 85,000 feet, it was kind of like a nice Beamer or Cadillac. But the airplane sensitivity was on a curve like this. So the faster you went, the airplane became much more sensitive and had to be handled much more delicately. The genius of this airplane was that the faster we went, it's the only airplane in the world, we burned less fuel.
So I just learned that was good for something other than surveillance. A little intimidation
that's
factor.
Exactly right. The 3 days before troops were going to be sent into Panama to remove Noriega, SR-71s overflew his house to kind of say, you know, with a shockwave, it's time to go because the Marines are not far off.
Yeah.
And it worked because they didn't have to come in aggressively because he had decided to flee the country.
Knock, knock. So I was always, growing up, I always saw the Blackbird and thought it was such an amazing, cool-looking aircraft. But I knew almost nothing about it until probably a year ago when I saw a presentation about it. And the engineering aspects of it are just phenomenal to me. It's amazing that it stays in the air to me, other than by sheer thrust. Can you talk a little bit about, I think we have some slides about, first of all, the temperature of the skins is amazing.
Let's start with the requirement, because when the U-2 overflew Moscow on the 5th of July, 1956, they were very surprised because they didn't expect that the Soviet radar would see the U-2. They didn't think it could see up that high. So from that flight and the flight on the 4th of July, which was over Poland and up through St. Petersburg, they could see that the Soviets were starting to deploy their advanced surface-to-air missile system. It was pretty soon that the CIA basically said, you know, the U-2 is vulnerable, but President Eisenhower felt that he needed to continue overflights and collect the vital information because we weren't sure, you know, initially how many bombers did they have and what were they doing with missiles. So he had a study group that came back and they told the president in 1957, this is what you need. You need an airplane that doesn't fly at 450 miles an hour. You need one that flies at 2,150, Mach 3 plus, not at 70,000 feet, but at 80 to 85,000. And the A-12 was up around 90,000 because it was lighter than the SR. And the third thing, which was Eisenhower's #1 requirement, and Kelly Johnson has it in his notes, I want an airplane Khrushchev can't see. So the SR-71 is America's first stealthy airplane. And not stealthy by today's standards, but stealthy by the standards of the late 60s through the 70s, before the advent of the 117, the B-2, and the F-22. So Kelly always felt this was his greatest challenge, was to meet what President Eisenhower wanted. And you can see from the picture there, if you're going to fly at those kind of speeds, even though the air up there is 0.4 pounds per square inch, when you're traveling at those speeds, it generates a tremendous friction. So the average temperature of the airplane is almost at 600 degrees. It grows 3 to 4 inches in length, an inch or two in width. The engine, when it's in fully operating, it grows 6 inches in length and 2.5 inches in width. So you can see the thermodynamics of designing this airplane was truly revolutionary. And like Kelly often said to people, I had to invent just about everything. And I'll talk to you later. The only thing you didn't invent was a new cockpit, because the cockpit was rather rudimentary for an airplane you're supposed to be flying at Mach 3. I treasure the time I had with Kelly. He could be rather gruff at times, but the good news was he liked crew members. And he used to come up to Beale, our home base north of Sacramento, about once or twice a year and talk about some subject that was on his mind. And typically you then go to the bar and you gave you a chance to more casually talk with him. I had probably 3 or 4. If you came back from a flight and there was a note in your box to call Kelly, you needed no permission. You called down to Burbank, they gave you a time and a telephone number, and he was cleared for anything that he wanted to talk about. Any questions that he had, you would answer to the best of your ability. Next slide. There's a special purpose for the black paint, and that's Pete Law. Kelly loves silver airplanes. You see, most of the A-12s are silver. And Pete Law came to Kelly and said, you know, boss, if I paint the airplane black, I can reduce the surface temperature by about 50 degrees at Mach 3.2. And Kelly said, I don't like that idea because I'm trying to get the extended range, and you're going to add 300 pounds of paint to my airplane. Well, the paint does more than just black reflecting the heat away. If you think about looking from below at an airplane at 80,000 feet, you're looking at a very black sky. So you get a little visual protection. But probably one of the most important things, in the paint, there's very fine ferrite particles. So as the radar energy hits the airplane, it slightly diffuses before it reflects. So it thereby enhances the stealthiness of the airplane. Trying to see from the slide, let's see. Next, there we go. Quartz glass, the oils are solid at 32 degrees, so you got to preheat. Part of what the Russians really wanted to know about this airplane, they could not understand how we could fly at those speeds for that time and not cook the pilot and navigator and all our equipment. We used the fuel as a coolant. The fuel would come out of the tanks and go to a heat exchanger. We would then take the now energized fuel and dump it directly into the engines and the afterburners. So we'd actually get more energy out of it. But the fuel was also used as a hydraulic because the nozzles in the afterburner were anywhere from 3,200 degrees to 3,400 degrees. That was the temperature back there. So your fuel was used as a hydraulic to control the nozzle. And then when it went through the nozzle, again, it was routed into the engines to be consumed and add to the energy. Next. 20% of the surface of the airplane, all this area here is a special graphite material. So as a radar strikes it, it's a trap. Those are the edges that are going to have the sharpest reflection. And so as the energy hits it, it gets caught inside, kind of like it goes in and then it doesn't come out. And that, again, enhanced. And you notice the tail slopes in. There's a reason for that. It's not a square surface. So as the radar hits the tail, instead of bouncing straight back, it bounces off at an oblique angle. Next. The SR-71, 35% of the air lift comes from the forebody. That's from where the wing joins the forebody. Think about the space shuttle. It's the same shape. So when we're cruising, our nose is 6 degrees up, like any of you out there when you're on a boat. The bow comes up so you can cruise on the water more effectively. That's what the airplane was designed for. So the nose comes up like a boat. We can fly at a higher altitude and we can do steeper bank turns. Now, when I say a steeper bank turn, we're not talking about a real steep turn. When the airplane heats up and is expanded, we could only pull 1.7 Gs. So 1.7 Gs is a 45-degree bank turn. And that's why it takes 170 miles to turn it around, because you can't pull it any tighter because you're afraid of bending the airframe. We've already talked about the sound of freedom. The pitch and the ailerons are blended together to call elevon. So as I put an input into the airplane, the pitch and the roll is blended across the back. There was a blending mechanism back in the tail that took those inputs and blended them together. Next. We assume it today, but think about an airplane back in the 60s. This was very complex. And they knew they were going to have trouble trying to keep it, the maintenance. So there are over 650 data points that are constantly monitored at different intervals. Like some of the engine ones are recorded every half second. And even that isn't fast enough, the way the engine sometimes inlets were reacting. So when we landed, they could download these tapes Every time I moved a switch, everything I said, everything the backseater did was all recorded. Because now you turn over an airplane that's had a chance to cool down and you tell maintenance, this didn't work. Well, it didn't work because of heat. So it gave maintenance a way to go back in and figure out, okay, at 2 hours and 10 minutes into the flight, the temperature of the airplane was around this, and the number 4 hydraulic pump was acting erratically. On the ground, they could run that pump and they'd never see the problem. They could see it from the tape, and then they'd replace that pump. And that's why our missions were very successful. Over 90% of the missions we launched were successful as far as the maintenance of the airplane. Next. And we don't think too much about it. You and I fly in airplanes now. Not only does it record the information, but it sends it off board. So when the airplane lands at the follow-on airport, they already have the part many times waiting for the airplane. Anytime you build a stealthy airplane, it's unstable. So as you look at the pedostatic, the center pipe on this measures your airspeed like in any airplane. Now, if you look at the side probe, the beta probe, you'll notice there's a hole on the top and the bottom on either side. The SR-71 is unstable in pitch and yaw. So it doesn't matter if you're hand flying the airplane or on autopilot. As the air is going over the side probe, it's sending inputs to the stability augmentation system to keep the airplane in control bounds. Without it, we'd lose the airplane, particularly at our high supersonic speeds. Roll was not important to us, and I'll talk more about that later. Pitch and yaw were where we were. Now, as you go forward, you get an airplane like the F-117. We kind of nicknamed it the Frisbee. It's got 4 probes going forward, 3 computers talking to each other. If it loses those inputs from those 4 probes or the computers crump, it has no sense of direction. The 117 is unstable in all axes. Next. Now look at this cockpit. A number of you out there are pilots or have flown in airplanes. I came out of the RF-4. They didn't allow me to get in the airplane until I arrived for Beale to start my training. And I got in the cockpit and I said, this is the cockpit I left. You just built us, a Mach 3 airplane. Were you cheap? And the thing is that Kelly said he had so many problems, you just need to learn how to fly it. So our indicated airspeed was about 335 at Mach 3 too. We used knots equivalent airspeed to see where we were. And of course, we had the Mach and the altitude. Angle of attack was very important. We were flying at about a 6-degree angle of attack all the time to be able to get that lifting body. Fuel, center of gravity. As you go supersonic, you move your fuel aft. You hold your CG as far aft as you can. Matter of fact, the one SR that caused the fatality, which was a Lockheed test engineer, they were trying to get more range out of the airplane. They figured the way they'd do it was move the CG further aft. They were over New Mexico. They had an unstart, which I'll talk about later. The airplane basically just disintegrated. Bill Parks was lucky, or no, Bill Weaver. He was thrown from the airplane, but it all successfully worked. The test engineer was killed because the way the airplane came apart. Now, when we started coming down from supersonic, we had to move the fuel forward. But what I wanted to point out, when you normally fly an airplane, your trim on your stick or your yoke is normally pitch and roll. We really didn't care about roll. We said it once, we cared about pitch and yaw. So that trim button was for pitch and yaw. Next. I want to show you, this is a step into today and into the future. I know there's an F-35 guy out there. I work for the company that came up with your main display there. 8 inches by 20 inches. You can select anywhere from 1 to 12 subsets. It's called HOTAS, hands-on throttle and stick. So you can literally fly this airplane, call your weapons, do all kinds of things with the buttons on a piccolo. It is wonderful for gamers. I've flown the simulator. I'm here to tell you, I have trouble. I'm an analog guy. Our gamers are going to love it. Now you add to it, and we're on, I think, the 3rd generation of the helmet, but your Heads-up display is in there. It's a virtual environment. There's sensors on the outside of the airplane that you can look down and around, and there is no airplane. In high-definition infrared, you can see all the environment around you. This is truly an amazing airplane. I just hope over time that we're able to get the cost per flight hour down. It's kind of in its initial stages, and it's pretty high. We'll just leave it with that. Next. This is the back seat. He cannot see forward. We have no connection between us. That big screen there is a radar. They filmed our map on 35mm film. I had a map projector in the front. He had one in the back, and it advanced at our ground speed. It was absolutely wonderful. The cockpit's so small, it would have been very hard to have been unfolding a map and say, okay, when do we turn? What's this coming up? It all came along with the map. It would tell you what was coming up, what was the expected fuel, you know, did you have to turn on a certain camera? Was your defensive system supposed to be in a certain position as you went along? He also had the radar was not a radar for air collision or weather. It was a radar mapping. And later on, I may have an opportunity to show it to you. What was truly amazing that the A-12 did not have, the A-12 had a basic inertial system. This system came from the British, the sensor, the astro-inertial. In each one of our hangars, like you see it behind me, the geodetic survey team came in and marked exactly where that was on the face of the earth. The team would come out 2 hours before we're going to start engines. They would upload everything about our mission and what we're going to do. We would come out and start the engines, go through all our checks. As we pulled out of the hangar on a sunny day, within 2 minutes, that sensor does not see the blue sky. It looks through the sky and locks on the stars. We guaranteed the president 300 feet anywhere in the world traveling at 2,200 miles an hour. And I know our F-18 guy and F-35, I can't speak on the F-35, but most of our inertial systems through our lives have a tendency to drift. The wonderful thing about this system, when you're locked on the stars, it stayed on track. We rarely were more than a couple hundred feet from where the president or whoever created the mission wanted us to be. So that helped with them to give them great confidence, particularly on peripheral missions. Believe it or not, overflights were not as tough. And why weren't they as tough? Because they'd already accepted any political problem that might come from it. You know, when you're over a country and you've already been decided you're going to be there, but when you're right on the border, we were the closest to fly to Red China, to the Soviet Union. We never flew them, but you take their international border, and we were 400 to 500 feet outside it, going along at Mach 3 plus, and it gave us an ability to reach further in to collect the information that we wanted to collect. Next. This is what it looked like. It was a 350-pound, and it's a glass window behind our air refueling there. Today, it would probably be 2 Apple Watches tied to the sensor, because think about the computers back in the 60s and the 70s. I mean, they were big. We had to use it, and you see the selection on the controller there was designed for somebody in a spacesuit with fingers that were not very agile. And obviously, this was something we learned from the Mercury and the Apollo program, but it was used also in the SR-71. Next. Defensive systems. Now, you probably say, well, gee, you're at 85,000 feet. You're going Mach 3 plus. Why do you need a defensive system? Well, the blisters on the nose that you see there are looking forward. We never worried about somebody coming from behind. And we're looking for air-to-air radars or surface-to-air radars. The moment they launch a missile at us, that circle you see underneath is a jammer. And what we did, we basically took away their ability to talk to the missile. Now think about it in the 60s or 70s, like I had a fighter squadron, you couldn't just fire a missile, you had to fire it, but then guide it all the way to the target. So we took away their ability. There was probably 100 missiles fired at us. I never personally had one. The closest missile ever to us was about a mile and a half or so behind us. After a while, they just gave up because they were just wasting missiles on us. Next. Very powerful engine. The J58 was designed with the Navy. They were going to put it on the, oh shoot, I got a senior moment. The F8 to try to give it a Mach 3 capability. But the engine weighs 6,000 pounds. And trying to get that on and off an aircraft carrier made no sense at all. So when Kelly was looking for a power source, he was aware of Pratt & Whitney's work here, but it was extensively modified. But the engine was really incredibly powerful and incredibly rugged, because the core of the engine was 2,000 degrees. The afterburner was it was the first adjustable afterburner. We had a min burner, 2 more stages, and max burner. So the temperature was anywhere from 3,200 to 3,400 degrees. As you go through about Mach 2 to 2.2, you've got too much air at the compressor face. So you start bypassing air. 6 bypass tubes start opening up. And what happens, you increasingly, as the faster you go, more and more the air gets bypassed around the engine, because the program manager, Bob Abernathy, basically said, we don't have enough air back in the afterburner. If we don't get more air back there, we're going to melt the back of the nozzles and the back of the engine. So part of the bypass was for cooling, and the other part was to have enough oxygen back there that burned that fuel that was coming through the afterburner lines. So when you get to Mach 3.2, 83% of the air is not going into the engine. It's going around the engine. So now you are a hybrid ramjet. That's why the faster we went, the less fuel we burned, because the fuel efficiency, we reduced our fuel flow by about 30%, but we increased our thrust by 50%. So Bob's got the patents on those. But I got to tell you the downside, every 400 hours, these engines had to go back to Pratt & Whitney and be rebuilt because of the thermal stress. We had a few of them come apart. We only lost 1 airplane because of it. That was the last accident we had, and the airplane ended up in the South China Sea. But we've never had an Air Force fatality flying these airplanes. So the crew got out successfully and were picked up by Filipino fishermen. Next. No jet engine can absorb supersonic air. Doesn't matter if you're in an F4 like I flew, or F-15, or the SR-71. At 1.6 Mach, you got to start adjusting the airflow. So that's the purpose of the spike. And I heard from one of the individuals the dynamics, because the decision was made to reduce the drag. We carried the shock in the inlet. And that led to some tricks as far as, or dynamics as far as losing the shock and having what we called an unstart. But at 1.6 Mach, the spike unlocks. It starts translating aft. It'll go a total of 26 inches. It more than doubles the opening. And what happens on the inside, well, figure this is the inlet, and this is the back of the spike. So as it pulls in, it reduces the throat by over 50%, so you have mechanical compression even before it goes to the compressor. And the individual was talking about the data there. Imagine, with 0.4 pounds per square inch up there, I was surprised if I didn't have 15 to 18 PSI at my first stage compressor. I mean, this is how efficient the inlet was in capturing that air and bringing it down. The limiting factor on the airplane was not airspeed, was not the Mach, although we respected the Mach for a number of reasons. The limiting factor was the temperature at the compressor, your CIT. 427 CIT, which is about 860 degrees Fahrenheit. So imagine you're feeding air into an engine already at 860 degrees, and now you're going to further compress it and burn it. So it was amazing. During the test program, it was not uncommon until they worked out a lot of the bugs that they'd have engines blow up on them, trying to get everything to work. Next. Basically, I was in charge of the airplane, the refueling, the overall mission per se. Our reconnaissance systems officer, he had the radios, he had all the navigation, he had the sensors, he had the defensive gear. He talked on like peacetime missions over the States. He did most of the radio calls to the different centers. I would do in the traffic pattern, taking off and landing, but the reconnaissance systems officer would take care of the rest of them, talking to the centers. Next. We used Gemini suits to start with. That's my backseater I went through training with, John Murphy. We flew together for 4 years. And as I mentioned earlier, these suits provided us all the protection. When you were flying with them, they were deflated. The cabin pressure was at 26,000 feet, and that's why you were breathing 100% oxygen. As soon as you went to start engines, your visor came down, and they time you. So it took 30 minutes before the takeoff, so you've reduced 50% the nitrogen in your blood. You normally took off and went to the tanker. That normally took another 30 minutes, so by that time you've reduced the nitrogen. So as you go to 26, you're not experiencing like a diver would coming up from the water. So we could fly the airplane at 26,000 feet, which reduced the pressure on the airframe against the very low outside. Now, we could take off with a full fuel load, but of the 12 airplanes we lost, 3 of them were in takeoff or practicing takeoff, and 1 of them on landing. Tire failures were a big issue in this airplane. Just like the Concorde that crashed at Charles de Gaulle, if we took off in this airplane and as soon as we got airborne, we catastrophically lost our afterburner, we're not going fast enough, and there's not enough airflow over the airplane to keep it flying under control. So by taking off with half a fuel load, we checked off 2 blocks. 1, we reduced the wear and tear on the tires, reduced the load as we lifted off, and secondly, it got us through that dead zone. We needed to get about 350 indicated. There was enough airflow at that point. If we lost an engine and afterburner, we could have controlled it. We practiced single engine approaches and landings, so it was something we could do. But just like the Concorde, what would have happened, we would have just gotten up, couldn't control it, 1 engine and afterburner, the airplane would have rolled over and would have gone in. So it never happened, but that's what we were avoiding. Next. The advanced suit is the same one that the shuttle astronauts on the first 4 missions of Columbia, the test missions, they didn't have their own spacesuits, so they borrowed ours. This was a better suit for us because we had more shoulder freedom than the Gemini suit had given us. As you can read there, it's 4 layers. I won't go into all the details, but the suit weighs about 45 pounds, and the helmet's another 10 pounds. If you're claustrophobic, we would suit up about 10 to 15 adults every year to give them the experience of what's it like to be in a spacesuit. When it came time to put the helmet on, about a third of them said no, they'd seen enough. They were they felt that they were comfortable in their little suit per se. So next, if you look at the front of it, on the right side, the valve there, that's where the cooling air comes in. You can control it. The silver, as you're looking at it to your left, we could inflate the suits in flight. And what did that do for you? Like my longest flight was 10 hours and 20 minutes. And the cooling air is not getting to all the places I'd like to have it. So I could inflate the suit and lift my butt up and move my legs around and my arms and do things like that so I could be a little more relaxed and then return it back to the deflated mode, because that's where we flew the in. Now on the right-hand side there is the harness, just like an F4 type of harness, at least the Coke releases. But that bulge across the middle, that's a Mae West. If you landed in the water unconscious, it automatically inflated, lifted your head up, so the anti-suffocation valve on the side of your helmet would make sure your head was above water if you were unconscious at that point. Next. The helmet, like I said, made 10 pounds. You're in the summertime out there, and you probably don't get as much fog in the winter, but the pilots had glass. The navigators had plexiglass. in both of them, there was a fine gold mesh, because just like in your car, when you got to put the defog on, as you exhale in your suit, in about 2 to 3 minutes, you're going to fog over from the moisture in your breath. So the heater was always on. You could kind of feel a dryness on your eyes because that's the heat coming off that gold heating mesh that's in there. There's a dual oxygen system. You wore cotton surgical gloves underneath. And the reason for that, they wanted to make sure your fingernails didn't dig into the gloves. The gloves were a layer of rubber and a layer of leather. So imagine when you're reaching around the cockpit for a switch you may not be able to see, or a circuit breaker, your sense of feel is really reduced. So as best we could, we tried to see what we were doing. It was not always possible. From the 3-9 line, from my shoulders back, there were about 50 to 60 circuit breakers. I couldn't see any of them. And we had a system that we would be able to count going out, going back, to locate a circuit breaker if we have to reset one or find if we were having a system malfunction, and see if the circuit breaker had popped on it. Next. Once you flew an operational mission, these patches were only worn by the pilots and the navigators. Only 85 of us ever flew an operational mission as pilots, and 86 as navigators. So that's in 25 years. We're not a big group of folks. We wore these on our flight suits on our T-38s. They were not on our suits, on our space suits. Next. Anybody associated with the program wore this. There were over 1,000 people doing vital different things that made this program successful, and it helped recognize that they were part of the overall SR program. They wore this patch. On the last patch there, the airplane, the Japanese, as the SR takes off, it takes a very steep climb, at least your perspective from the ground, because of the speed. On Okinawa, they have Cobras. Think about how a Cobra goes. It flares up. And they call their Cobras AHABUs. So when they started seeing Blackbirds taking off, the natives called it a AHABU. The Air Force never named it. So guys before me adopted it as the sign that you'd flown an operational mission. You were part of the AHABU program. Next. This is a map. This is a speed run that from London to Los Angeles, 3 hours and 48 minutes, flown by Buck Adams and Bill McCorrick. And you can see that's the whole route right there. And the cockpit is small. This was strictly a backup map. But I'll tell you I'll say a funny story. We could not control our shock. That's a fact of nature. So as Buck was making his turn over LA, having set the record, we're now learning, as we're trying to develop supersonic commercial airplanes, that when an airplane goes into a turn, sometimes the shock gets concentrated. And what happened over LA, the shock got concentrated, and he broke windows in about 20 to 25 houses in the Los Angeles area. But everything on the airplane's recorded. So we knew right away that the SR was the culprit. Well, one of them was Zaza Gabor. And the Air Force said, hey, we got an opportunity for a PR deal. So they send down Buck and Bill and their 2 wives to personally apologize to Zaza Gabor for breaking her windows. So I don't know all the details. I think she probably sent the butler out. And the butler's words were, bring the pilots, leave the wives in the car. So she entertained the pilot and the navigator for about an hour and a half, and then sent them on their way. So it's one of the funnier stories. I finished a Cuban overflight, and I was making a descending turn over Mississippi. And my shock concentrated in the Hattiesburg area. And that particular day, we broke windows in about 30 houses. But the Air Force was very quick to get out when we got reports from people that we'd broken windows. We tried not to fly over major cities for that reason. Next. Most of our missions, you spend 4 to 6 hours in the suit. Most of the flights were 2.5 to 4.5 hours, 1 or 2 refuelings. That's either 3,000 miles or 6,000 miles. The longest mission ever was 11 hours and 25 minutes. That's from the East Coast of the United States all the way into the Middle East during the Arab-Israeli War in 1973. And that was because no European country would allow us to fly. They were afraid of an oil embargo. So we had to fly those missions out. 95% of the pictures, the president and the people around him evaluating what was happening in that war came from SR-71s flying into the Middle East. This was the advanced suit, and my longest time in the suit was probably 12 hours. My mission at 10 hours and 20 minutes, I was in the suit about 12 hours. Next. You were literally installed in the airplane. You got in the seat, you put your arms up on the rails, and you watched the two technicians. And when one did something on the right side, the fellow on the left side or gal checked it off, vice versa, back and forth to make sure all the straps, the connections, everything, the ejection seat was properly, you monitored it. They were absolutely great professionals, and they're the ones that maintained our suits also. Next. This is a Buick start card. It's a pair of Buick Wildcat engines. The engines, because of their large weight, it took quite a bit of torque to turn them over. There was a drive shaft that went up into the engine. At 1,000 RPM, we would bring the throttles forward. There'd be a shot of triethylene borane. TEB, because of JP7, most jet fuels ignite at -40. There's enough fumes. JP7 was specially designed for this airplane. It doesn't get significant fumes until you get it above 180. So we used a chemical ignition. So when you start the airplane, there's a shot of TEB. It explodes at 3,000 degrees. That's that green flash you see there. It's triethylene borane. Every time you lit the afterburner, another shot would go into the afterburner section to make sure you got a clean light. Now, off the West Coast now, they're going to start testing hypersonic vehicles, hopefully later this year, but next year. Take a note of what they're burning. It's JP7, because JP7 is very stable at high temperatures. All that fuel you see in the picture, and you're going to see more here in a second, there's really no fire hazard. Your biggest hazard is slipping on it, because it's oilier than a regular jet fuel. Next. And why does it leak so much? Think about it. You can't use rubber bladders because of the temperature. So they built the tanks as tight as they could, knowing they had to expand because of heating. So they used silicone to try to seal the edges. And every 100 hours, all the tanks had to be opened up, and the old silicone had to be removed and new silicone, but it always leaked. My wife was around the airplane before I was in Okinawa, Japan. And she came back and she said, pull that, your volunteer statement. It's the most dangerous airplane I've ever seen. And I said, why is that? She said, because all the crew chiefs are wearing raincoats. There's fuel dripping from everywhere. So if you're not accustomed to the fuel, you thought you were observing a major disaster. Next. You can see the cross section. The engines represent the largest drag on the airplane. The body is very streamlined. And this is the genius of Kelly Johnson and his aerodynamicists. And you can see, we're looking at it, that boat-like effect that allowed that forebody to give you that 35% lift. Next. Your greatest sense of speed is on takeoff. You're cleared to take off. You release the brakes. You light the two powerful afterburners. Within 20 seconds, you will have gone about 4,500 feet, and you're lifting off doing 240 miles an hour, 210 indicated. You'll pass through 20,000 feet less than 2 minutes from the time you release brakes. If you go all the way to altitude, it's going to take you 17 more minutes. You're going to burn a third of your fuel. You're going to climb 60,000 feet. And from 20,000 feet doing 400 indicated, you're going to level off doing 2,150. The only airplane in the world that can climb and accelerate like that at the same time. Next. This is the sight I was telling you about from the tape. 350 miles in any direction. It is absolutely spectacular. At night, imagine 90% of the stars you can see up there we can't see down here because they're so faint that the atmosphere filters them out. Next. These are our cameras. It's a magnificent assortment. We had 2 side cameras controlled by the computer that could reach out about 25 miles, 20 nautical miles. The resolution was 2 to 4 inches. So if the Adventure Club was out in the parking lot, it's daytime, and I flew over at 85,000 feet doing 2,150 miles an hour, I would take your picture and I could see every single one of you. I could not recognize your faces. But if you're standing beside your cars, about 70% of the time I could tell you what kind of a car you were driving. That big blue line across the bottom there is that picture that's 72 miles wide. And it also, in the center, has 2 to 4 inches of resolution. When I flew the special mission for President Carter, that was a camera I was operating, the primary camera. And we flew the whole border between Saudi Arabia and Yemen because they were in the product of having a war. When I was in the program, we got the advanced radar, the synthetic aperture radar. We could move it from 25 to 85 miles out. It was 12-inch resolution. I can't see people. I can't identify cars, but we're getting away from blobology. And I could do strips out there out to 100 miles with 10-foot resolution, which would give me a general sense. Next. This is that nose camera. Look down below. You can see the boats. I realize it's kind of hard to see where you're at, but you can see the parked cars. You can see in the parking lot on the negative, you can see the stripes between the parking spaces. This is the quality of the film we're delivering in the 70s and early 80s. Next. This is the new. Look at the resolution that you can see from radar. It doesn't matter. You can fly at night. You can fly in the weather, and you can see roads. You can see infrastructure. You can see if an aircraft hangar is occupied, a sub-pen. So many things that before we couldn't do. One of the things we found out that if an aircraft hangar were occupied or a sub-pen, when the radar goes in, it comes out looking one way. If the hangar or sub-pen is empty, it comes out looking another way. So when we did an inventory of the Soviets' northern fleet, we could do a sub-pen inventory, and we could tell who was home and who we needed to look for. Next. This is that side camera controlled by the computer, and it would turn. That camera head would adjust to, they knew we could take up to 1,800 pictures in a roll of film of 1,500 feet. Next. Every 2 hours, we'd burn basically the 12,000, or taking a significant part of the 12,400 gallons of fuel, the 80,000 pounds we had on board. So about 220 miles back, we had to start down. This was one of the major hang-ups for our navigators. We washed out more navigators because they couldn't start thinking. They came out of airplanes that were flying at 7 to 8 miles a minute, and now I'm asking you to fly at 32 to 35 miles a minute, and I need an accurate descent, so when I come down at 25,000 feet, I'm no more than 1 mile behind the tankers that I need the fuel from. So we have to start down. There's a special profile, because once we come out of afterburner, we got to allow the airplane to start cooling and contracting, but also we have to keep the engines at certain speeds so we do not get compressor stalls that could cause the engines to flame out. Next. You can see the air refueling receptacle was fairly well back. Normal refuelings are 12 to 15 minutes. We refueled on every flight, became routine. 1,000 gallons a minute. We could talk through the pipe. It was the first program that was wired, so we could talk to the tanker crew and say, okay, when you do your message, please pass this on. So we didn't have to break radio silence. On most operational missions, we ran silent, except for President Carter. You know, he was such a micromanager. I had to break radio silence 5 times during that flight to say, we just successfully refueled and we're on our way. You know, even though there were a lot of other sensors out there showing exactly where we were. Next. You can see we're tucked in pretty tight. Without our tankers, this airplane would have never been operationally relevant, because the places we had almost 26,000 refuelings during the program. I know of no time that we ever had tankers not where they were supposed to be to give us the fuel we needed. They were really a great group of very professional men and women. Next. For you pilots, when you pull underneath, we didn't use it so much in the day because you kind of see where you're at, but at night and in the weather, there's lights on the bottom of the tanker. There's a stripe in the middle that tell you that's the middle, but on the left-hand side, if the light way in the back towards the aft end of the airplane is lit, you're too far back, so it's telling you to come forward. If the forward light's on, it's telling you you're too far forward. Come back and put the light in the middle. The same thing on the right-hand side, but if you're way in the back, it's telling you you're too high. If you're way in the front, it's telling you you're too low. So that was a way, using lights in the weather at night, to be able to hold the position that the boom operator who's feeding the fuel into your aircraft can keep the pipe and keep the refueling taking place. Next. Do we want to cover operations or just go ahead, jump on. Next slide.
Sure, go ahead.
Strategic reconnaissance, we've already talked about booming and using the sound of freedom as a way to make a statement. We also, sometimes, we did what we call coordinated sorties. And I flew a couple of them that had like 28 different sensors. And what I would do, and what we would do, I'm not the only one, we would come at the Soviet Union particularly, sometimes Red China, in a provocative manner. We would not overfly them, but the whole thing was to stimulate them. They were kind of Pavlovian. They always wanted to get an SR. So we would, it was all timed. So there'd be overhead satellites, other airplanes, ships at sea, and land sites, because when we showed up, the Russians turned on everything. It was amazing. They launched fighters, the missile sites came up. A couple of times I came back and I landed, and the head of NSA from the Far East was there. And he said, what kind of reaction did you get today? And I said, well, it's pretty normal, not too much more. Well, we told the Russians yesterday you were going to be there, and what time to look for you. They wanted a more robust reaction because they really felt that we were invulnerable. And pretty much so we were, but you know, you never know when you're going to have a mechanical failure. Next. These were the sites. Main operating was Beale, north of Sacramento, Mildenhall, near Cambridge, Okinawa, Japan. And I'm only one of two pilots that took the SR to Diego Garcia. And I'm here to tell you it's a very small island in the middle of the Indian Ocean. The closest island, which was an abandoned World War II site, Gun Island, it was 800 miles away. So you better find the island. There's a funny story associated with it. The way the navigator system worked, we had a star catalog for the northern stars, 58 stars. We had a star catalog for the southern stars, 58 stars. We rarely flew. Think about where the equator is. Look at the conflicts up there. We were rarely south of the equator. Diego Garcia is south of the equator. So we're coming out of Japan. We're filming Vietnam, come across Thailand, enter the Indian Ocean. And as we approach the equator, all of a sudden the navigation system's not working. The starlight's off. And so we're talking to say, I wonder what. So I said, okay, we're going to use dead reckoning. I think we can find that island. So when we land, the technician is there, and we describe, and my navigator and I say, you know, did you put in the Southern Star catalog? And you could just see this look on his face of, oh, shit. That's right. We're 4 degrees south. So the answer was 2 days later, we want you to take off and circle over the island, get up to altitude, take up a heading to the northeast, and we think when you cross the equator, it'll start seeing the stars again and navigate you back home. I rest my case. Next.
Like the wheat.
It worked. This was a typical Vietnam sortie. They were about 4.5 hours. There were 2 refuelings. You take off, refuel, come down, swing over the top edge of South Vietnam. up over North Vietnam, Laos, sometimes into Cambodia, refuel in the Gulf of Thailand or over Thailand, retract the course or a similar course back over and then back into Okinawa, land, they download the cameras and everything and they process it there and send the messages out. Next. This is the longest mission. You'll see East Coast of the United States because, again, the Europeans wouldn't let us in. When I flew the mission for President Carter in March of '79, that's the first time that the Brits had ever allowed us to fly out of England into the Arabian Peninsula and come back and land because they had their North Sea oil fields, which gave them some. The French wouldn't let us overfly. It could have been a 7.5 hour, 7:45 mission. So I had to fly around Portugal and Spain and swing through Gibraltar all the way through. So I had a refueling off Land's End. I had a refueling off near Sicily. I had tankers come out of Cairo that refueled me in the Red Sea. I had another set of tankers in the Red Sea, and my last set of tankers came out of Spain, and I refueled north of Libya to come back in and land. Next. This is the route they flew during the war. When you overflew a country, you had to be above 75,000 feet and 3.15 Mach. And it didn't matter where you were, your defensive systems had to be active. Next. Came into land, it's pretty high speed. 95 knots approach, you touch down, 175 knots approach, 155. I normally, with the drag chute working, you normally came to a slow taxi speed of 4,000 to 5,000 feet. If that drag chute failed, it was going to take you 10,000 feet of runway to get this airplane stopped. So I normally tried to touch down around 146 to 148. So if the drag chute didn't work, it was easier for me to bring the airplane. I never had a drag chute fail. And the mechanism, you could kind of tell new guys, because it happened occasionally, was up in the cockpit. You'd reach up. It was a T-handle. You'd pull it back. The T-handle opened up the drag chute doors. A little chute came out, and the big chute pulled. When you hit about 50 knots, you didn't want there was a big buckle on it. They didn't want that buckle to bounce across the back of the airplane. So with the chute still fully deployed, you push the handle back in, and the chute would fly away from the airplane and land on the runway to pick it up. Imagine you pulled it, the drag chutes come out. It's like the hand of God reaching out of the sky, because all of a sudden the airplane starts a deceleration. So now your head comes forward like this. What if you still have your hand on that T-handle? You push your hand so you don't hit the instrument panel. So you push it in, and guess what? There goes your drag chute. So you could normally tell it wasn't a drag chute failure. It was a technique failure on the part of the pilot. Next. The brakes were undersized. They were always overheated. So as soon as we stopped, fans were put on them to try to prevent the tires. Those tires were inflated to 425 PSI in nitrogen, because if you put air in them during the flight, they would heat up and the oxygen in the air would have bounded with the rubber, and you'd come back with slightly deflated tires, which would compound your tire problem we already had. Next. That's the last picture of the fleet. At any time, we had 10 of the operational, the A models. The trainers in the back, we had 2 trainers. The trainer had an elevated rear cockpit. So the instructor pilot, that's where I sat the last year and a half, with a student in the front or giving annual check rides. There were controls in both cockpits. All the rest of the airplanes, the navigator had no flight control. So if the pilot became incapacitated, that was the end. The SR had no competitors. When it was retired, we'd just gone through almost a decade of upgrades. We now had a digital flight control system that was wonderful, all kinds of things. So why was it retired? The Cold War came to an end. They felt it was going to be a more peaceful world. We won't be doing as many overflights. The second thing was costing $85,000 an hour to operate. When I was flying the bird, it was about $50,000 because the tanker, the special fuels, all the maintenance and everything else. But you know the real reason, I think, or the primary reason, when I flew that mission for President Carter, 4.5 hours after collecting the information over Yemen and Saudi Arabia. I landed in England. They downloaded the cameras and the sensors, put it in a waiting airplane, flew it across the Atlantic. He monitored my whole flight from the Oval Office. They flew the film across. I talked to the processors. My nose camera took them 12 hours to process the film. Now you got to analyze it. Now you got to get it to the president. So I'm guessing the president may have gotten the photography with his military leaders about 36 hours, maybe, after we took it. Think about the world we live in. This airplane never developed a data link. The U-2, our satellites, our Global Hawks, our Predators, you name it, they all have data links. As they collect the information, it's delivered to our decision makers. We live in a world that our decision makers want it in minutes, maybe hours. We were delivering film and results in hours and days. So I really think that was the most significant characteristic on why it was retired. I'm open for questions. I hope I've stroked a few interests out there. It was a truly amazing airplane to fly.
I have a couple for you, and then I'm sure there's a ton of people out here. When you, we're talking about turning radius, just to give a sense of scale to people. If you needed to do a U-turn in that thing at speed, what kind of territory are you talking about?
You could do it in California, but you couldn't do it in the Northeast. You'd take a number of states, about 175 nautical miles across. Yeah. At 3.2 Mach. That's why it's kind of interesting. If we're going to go to Mach 5 and Mach 6 with these hypersonic vehicles, you think what they're going to have to do to turn them. You're going to double that amount. So you're not going to be going back and forth over something. You're going to make if you're reconnaissance, you're going to make a high-speed pass. If you're after a target, you know, you're just going to go after the target.
And I have to ask this. Did you ever have a holy crap moment?
Oh, yeah.
Tell us
Matter of
about
fact, on that mission for the president, the head of MI5 and MI6, the head of Strategic Air Command Operations, a whole bunch of people, the deputy ambassador had been at our briefing. We got out there the first night, and there was blowing sand. We got out the second night, blowing sand, and the White House is really getting angsty because they need the pictures to try to understand what they can do with this conflict. So that second night, I had the seafood dinner at the Milton Hall Officers Club. Well, as I take off, I'm feeling kind of uncomfortable, and I'm normally pretty good. So I get to Land's End, and my second tanker I'm refueling on, I have a huge diarrhea attack.
Uh-oh.
And then, so my backseater and I are talking, and of course the tanker can hear, and it's on the tape. So I made the statement. I said, I do not want to abort this mission and have him send a message that the pilot pooped in his suit. So we tried to figure out, because I had 9 hours to go. I'm sitting in this stuff. And so we decided, it worked out. When I came back to land, and I had a nose gear that I had to use an emergency drop on it because there was a mechanical problem with it. So as I pull up, there's about 125 of our support people and the vice wing commander. And I kind of tell people, kind of back up, you know, this is going to be kind of aerobic. I get to the bottom of the ladder. They know what happened. So they took a black SR tie-tack and painted it brown and created a certificate for me for the first Mach 3 turn. If you were in this program, you could not be thin-skinned. They were great practical jokers. So at the first opportunity, somebody was going to figure out something they could pull a joke on you.
That's great. Well, thank you. We have some questions out in the audience.
All right, I see a bunch, but I'm going to start with a couple questions from my dad who's watching back home. First, he wanted to ask if the MiG, can you hear me, Buzz, by the way?
Yeah, I sure can.
Okay, great. First, he wanted to ask if the MiG-25 was the Russian attempt to counter the SR-71. And secondly, why didn't the YF-12 interceptor version go forward?
Okay, the MiG-25 was actually developed by the Russians to counter the XB-70 that was never produced. It was tested, but they were concerned about a supersonic bomber. the MiG-25 was the most successful fighter in my time period to try to come up and intercept us. He could actually get up to, not to 80,000 feet, he could get up more like 70, but he could get to Mach 3 for about 5 minutes or so, but he burned up his engines. I mean, he could get back home, but the engines had been over-temped, and they basically had to trash them. The MiG-25 was really never a threat. And most of the time, the way if you can imagine, the ground controllers often tried to vector the MiG-25 to do a stern conversion on us. Well, the MiG is a beam us, and now he's going to turn. The time it takes him to make the turn, I'm 150 miles up the road. So I heard some tapes from Russian interceptor pilots, and I've never heard so much swearing in my life that have been translated for NASA for us. Your second question, the YF-12A was actually a very successful airplane. It knocked down targets more than 100 miles away, but there was a couple factors. One, unlike an F-4 that I would later fly, where you could jump in and hit 2 buttons, be on the 5 to 10 minute alert, do your parachute, start heading out. It takes almost a half hour to get this airplane to do the test and get it started. The second thing, when you're in a pressure suit, space suit, you immediately start dehydrating. So your pilot and weapons controller in the back, as soon as you put them in the suit, you got a kind of a clock. So you're going to have to. They decided the threat wasn't as great, but I have to say the brilliance of the program, because the test missile and the YF-12A that was so successful was developed by Hughes. And what they did, because the program was very classified, Hughes was given permission, or the Air Force did it. I'm not sure exactly had the interface, but they went to the Navy and they said, you know, you've been working on that F-14, the Tomcat, you know. We got these Hughes scientists on the weekend working in their garage. They've been working on this missile that maybe you might be interested in. Not relating it to the YF-12A program. That's the Phoenix missile. So at altitude, it was good for over 100 miles. The way the Navy used it, you're getting over 50 miles at lower altitude. So that was effective use of the investment that went into the testing that showed that the Phoenix was a very effective missile.
Thank you so much. Next question we're going to take from the chat. Thank you all so much for tuning in. So glad you could all make it. The question is, you mentioned that the planes were retired at the end of the Cold War. Assuming they're still around, what are the conditions under which you could see them being pressed into service once again?
Probably not, because the whole industrial base that produced them and all the technicians, you know, they brought them back in 95 and retired them, the ones we brought back in 97, because the Air Force really didn't want them in the inventory. So they never used them operationally during that time period. Of the airplanes, the 20 that survived, I would say half of them were not cut. To ship them, a moving company would come in and cut the wings. Those airplanes could never be used. Now, like the Air Force Museum, the museum at the Smithsonian, those airplanes were flown in. Those airplanes are perfectly fine. With today's technology, you could probably put a data link on it, but I think they would probably be looking for other means instead of resurrecting the SR program, because you're pretty much 3.5 is probably all you're going to get out of the airplane. It was tested at that, but it was super sensitive. I never talked about the unstart. This is a good time to talk about it. You've got basically 3.2 Mach, or as you're going up to it, you got 2 inlets, engines, afterburners that are working together. All of a sudden you get a disturbance on one of the inlets and the shock has been spit out. What happens instantaneously, one side is producing whatever 100% thrust at that particular setting is, the other side is more like 20 to 30%. The engine normally doesn't flame out. The afterburner is blown out. So what happens, you feel it in your butt. Man, the airplane starts a violent slice. And that's why they put, you're talking about Bob Gilliland, that's what he had to live with to develop an automated system. So When one side unstarted, the other side sympathetically unstarted, and the spikes went forward to try to re-grab the shock wave and bring it back in. Didn't always work. I had about 100 unstarts during the time. I used to fly test tops. The worst time I had 7 of them in a row on the DMZ, and the airplane was really going unstable. Broke my visor, my sun visor on my spacesuit. But it was a case where my emergency procedures said I needed to roll the airplane out and stabilize it. If I'd rolled the airplane out, I would have overflown North Korea, which would have been a political violation. So I had to nurse the airplane through the turn. We broke one of the main, because with the unstarts, it was twisting the airplane. It broke one of my main hydraulics lines. So I ended up having to make an emergency recovery at Osan Air Base, an American air base. It's about 45 miles south of Seoul. Get maintenance to come up and fix it.
Yeah, Buzz, Michael Lawler, 1195. Thank you so very much for your program tonight. We're really, really enjoying it. I have a question about the SR-71 that is over by the Coliseum, between the USC and the Coliseum there. Maybe you know that plane. I was wondering if you could
Titanium Goose.
I was wondering if you could tell us anything specific about that particular plane, because I happen to see it when I'm going to the SC football games and like to tell some stories to the kids. Did you fly that plane, or what can you tell us about it?
That's the A-12 trainer. It never went Mach 3 because in the first part, when they were training the pilots, they were using J58 engines, as I recall, so they could get up to Mach 2.2, something like that. Kelly Johnson's only flight in a Blackbird was in that aircraft. If you see a picture with Kelly around the airplane, it was that one. He never flew in the SR trainer. But that was a trainer for the A-12 program, which was a single seat. You know, he didn't have a navigator or an RSO back there to help him. And you notice it's silver because Kelly likes silver airplanes. It wasn't until really the SR-71 came along that the decision was made to paint them black for reducing the heat and also give us a little bit of a camouflage protection and reduce the stealthiness. I should say increase the stealthiness.
Thank you so much. Next question from the chat. What do you think set you apart from the other candidates who were considered to fly the plane?
They liked people that had flown multiple airplanes. They liked the idea that I'd flown a big airplane, a 141, so I had worldwide experience, and that I had refueling experience and combat experience in the RF-4. So when I was in the program, at any time there were only 11 of us, 11 pilots and 11 navigators. So we were a small group, and anytime 3 whole crews were always in Japan, sometimes 2 in England. So you can see training at home. Of the 11 pilots, when I was in the program, 8 of us came out of RF-4s or F-4s. We had one 105 guy, one B-52 guy, and one T-38 guy. That was our complement. And that's what they looked for. And they didn't look for a fighter guy who yanked and banked, because even if the airplane was cold, quote, we hadn't taken a supersonic, you could only pull 3.5 Gs. Because the way the airplane was built to expand, you could bend it, they think, fairly easily. I was lucky, too.
Buzz, I wanted to know if you made it to Bob Gilliland's memorial service.
I most certainly did. I most certainly did. I wouldn't have missed that for anything. I thought the world of Bob, and he was part of my graybeards. I still have a group that when the different museums come up with questions, I turn to these men and women that served in the program in whatever capacity. It could be the Skunk Works, could be Pratt & Whitney, could be wherever, to help answer questions that young men and women or whoever asked at these various museums.
Yeah, he was one of my best friends also, and I was there as well. And you know, a quick couple of anecdotes. A lot of the guys here didn't know him. But one time we were talking, and he always had that twinkle in his eye, you know. Even when he was in his last days, And I remember one time he looked at me and we were talking a conversation, and he adored Kelly Johnson. He thought he was the greatest thing since Swiss cheese. And he looked at me with a twinkle in his eye and he said, you know, Kelly Johnson would have never hired the #2 test pilot in America. I thought that was pretty good. And the other thing he mentioned was that, because Bob was pretty tall. He's, what, about 6'1" or 2.
Easily,
And most of the other guys were pretty short. So the escape hatch that you pull down on, that strap that you pull down on for the canopy to get out, they had to extend that. And because it was in there just for him, and then everybody else was shorter. So they made that strap longer so he could get to it. And so the other question I had for you, did you know Ed Yielding at all?
Sure.
And
I helped recruit Ed for the program. He came out of the same RF-4 squadron that I'd come out of in Okinawa. And so he arrived the summer that I left. And of course, he's the one that set the record in aircraft 972 from Los Angeles back to the Dulles Airport in the Smithsonian.
Yeah.
You know, the Air Force was kind of cringing because on the last flight of that airplane, it set 4 new world records.
How about
They
Brian?
wanted it flown subsonically, and between Lockheed and some senators and some others, they weaseled their way around, and so Ed and Joe Vita could fly that last flight and set all those records.
That was pretty cool. He was there too. Ed was there.
Yes.
How about Brian Schul?
Brian Schul was removed from the program for disciplinary problems, and he's considered a pariah. We have no dealings with him.
Yes.
He gets a lot of money for his books. His pictures are fabulous. Many were taken illegally, but too much of the information he puts in there is inaccurate, which is really unfortunate.
Yeah. Thank you.
He's you know, the sad thing is he survived a terrible accident in Laos. I mean, for a while they didn't even think he'd ever walk again. He got back on flying status. He passed the physical for the program, and then went out and did stupid things and lied about it. As I told you, everything on the airplane was recorded. So he said, no, I didn't do that. And they go, well, wait a minute. The recording said that you flew over your girlfriend's house at night and lit the afterburner. No, I didn't. Well, look, the record. And the sheriff had 45 calls on what was going on at Marysville. He self-destructed. It's really unfortunate.
Thank you
One
so
more
much.
quick statement about Brian Schul. He gave a talk here at the club a few years ago. I don't know if you've seen his video or not, but he is a very good speaker.
He's a great speaker.
He's a great speaker. And he told that story about flying over Phoenix, and he tells the story about the little Cessna calling for his height or speed or whatever, and he does the ground speed, and he does such a great imitation, and he goes through all the ranks, and then he gets the Navy guy, and then he thinks this guy's got to die, right? And it's just such a great story for the SR-71.
It is. As a docent, I often get asked about that question. Did it really happen? And we don't know if it's a story or true, but it very well could have happened because we were monitoring, center frequencies. So I've tried to talk to his navigator, was flying with him, Walt, and Walt always kind of refers me to something else. So I think it probably happened. But there's funny things. I'll give you one quick one, because when we flew in the United States, we used the call sign Aspen, as in the tree. And that would tell the senators so we were an SR-71 and we needed special handling. Well, Minneapolis Center wasn't used to handling us. This was a winter day, and I was leaving one heck of a contrail. So Minneapolis Center was getting calls on what was that streak up there, because it was so cold. I was actually leaving a contrail at 80,000 feet, which in combat would not be a good deal. But my backseater called Minneapolis Center and said, Minneapolis Center, this is Aspen so-and-so requesting clearance to flight level 600. Well, the controller in Minneapolis doesn't know who we are. So he comes back and says, Aspen so-and-so, how are you going to get up to flight level 600? And my backseater goes, Okay, 1 potato, 2 potato. He goes, Minneapolis Center, I'm requesting permission to descend to flight level 600 to come back in controlled airspace so I can turn south. And then there's a pregnant pause, and all of a sudden you hear, Aspen so-and-so, you're cleared, flight level 600, because now he knows who we are.
Thank you so much. Next question is from the chat. Tom Dietz, thank you for the question. Have you ever flown the U-2? And
Yes.
what are the challenges with that aircraft?
You are looking at two ends of the flight spectrum. The U-2 takes off typically in about 800 feet. Things happen fast, and you've got to watch your climb and everything on it. When you come back into land, you got to stall it. And the rear wheel has to come down first, because you land on the nose gear, it's going to go all the way down the runway in ground effect. And if you come in on a no-flap approach and you're about 1 to 2 knots hot, you're not going to land. It'll go the whole length of the runway. So, you know, it's got the nickname the Dragon Lady. When you go to take off and when you come into land, it's a dragon. And it can eat your lunch in a heartbeat. At altitude, it's more like a lady. And now with the new engines in it, the GE engine, you know, originally their Mach tuck to stall was about 7 to 10 knots. The early U-2 pilots really had their hands full. Now with the new engines, it's more like 20 to 25 knots. It's a wonderful airplane to fly. Now you think about it, the SR was the opposite way. High-speed takeoff, but very predictable. High-speed landing, good instrument landing system. At altitude, we were busy to make sure that, as we said, the pointy end stays forward, and we make sure the airplane is doing exactly what it's doing. The U-2 at altitude, with the autopilot on, was, I won't say docile, because you had to monitor it, but when the U-2s first came to Beale, I was in, I can't remember, I was in base ops, or I was doing something, and one of the U-2 pilots just mentioned, so I'm going up tomorrow, doing a test run off the West Coast for Edwards or something. It's a novel mission. So he got my attention. I go, a novel mission? Can you share with me what you're going to be doing? And he starts kind of chuckling. No, I don't know, Buzz. Kind of secret. It's a novel mission. I'm going to be up there for 8 hours doing this 300-mile racetrack. And then he finally goes, you know what a novel mission is? I said, no. He said, I put the autopilot on and I take my novel out and I read it while the airplane's flying around this loop for 6 hours. So you can see it's kind of a little difference. But my last flight in the Air Force, they gave me a choice. You want to fly a T-38, or do you want to put on a spacesuit one last time and take a U-2 to 70,000 feet? And I said, is there any question there? Get a suit out. I want to take it up one last time and thank the Air Force and the taxpayers for paying for all my flights, particularly the SR fuel. U-2 is an amazing airplane. You know, it's going to be around. I'd be willing to bet that some version of it will still be around at 2040 because it's economical. It carries a heavy load. Yes, it's piloted, but then you got the pilot in the interface to help with the decision making. And it's doing remarkable things. Just recently, there was an airborne test where U-2 had a special communication node on it that they could take direct communications from F-22s and F-35s, and they could feed it directly to both of them in real time and also down to an Army ground site. Because the F-22 and the F-35 have different communication systems. Go figure. Same company, but the way the contracts were written. So now we have a way that we can get information across the battle space and use the U-2 with a special node that translates those three factors so they're all talking to each other in real time. So it's going to be around for a long time.
Hi, Buzz. Fred Gracholski, 1174. Thanks for the overflight in March of 79. I was on the USS Constellation, a nuclear weapon technician, and Combat Information Center, and we watched when the liftoff was, and we waited till it was over. But thanks a lot for the flight.
It was my pleasure. We were the junior crew. The senior crew Stanivel brought the airplane over, and they didn't like longer flights. So the senior pilot came to me and said, Buzz, hey, I got an idea. We brought the airplane over. That's 4 hours and something. Why don't you and John take the first flight, the second overflight you take the third overflight, and then we'll take the airplane home, and we'll both have about the same amount of time. I said, okay, I'll do that. I'll fly the first mission. I'm glad to do it. Well, even to this day, he goes, you tricked me. There was only one mission. So the senior crew bought the airplane over for the junior crew, who flew the mission for the president. And we gave the airplane back to the senior crew to take it home.
More questions from the chat?
We have one more question from the chat. Can you talk a bit about the recruiting process for the project? What was it like? How were you approached? And what was sort of the screening process like?
Well, I was approached serving in Vietnam by this Colonel Jerry O'Malley, who had flown the first operational mission in the SR-71, and he would later become the SR-71 Wing Commander. And he liked the way I flew, what I did professionally, and he said, you're the kind of guy we want in the program. So if you're interested, stay in contact with me, and I will make no promises, but I will make a statement that if your records look like they're worth reviewing, that they ought to bring you in. Now, he had already left the wing before my records were finally reviewed and brought in, but that kind of gave me an edge, at least to have the records looked at, because there were probably half a dozen to a dozen pilots and navigators every year that put their records in and hoped that they'd be looked at. When you came back, your first thing was a 2-day astronaut's physical. They ran you through to see if there were any physical things that were going to be limiting why you couldn't come in the program. You then had a series of interviews with some of the current crew members and some of the staff. As a pilot, you then flew in the T-38 with a current SR pilot because they wanted to see how you flew. Were you a high G burn, or were you a smooth? Because they were looking for somebody who could think ahead and operated smoothly. For the pilots, the SR-71 was the first computer simulator I'd ever seen. It flew just like the airplane, although it had no visual. So you couldn't imagine takeoff, and you couldn't do refuelings. But basically, it flew just like the airplane. So what happened to me was what I would later do for candidates when I was an instructor pilot. We'd take you in the simulator in the morning, and I'd walk you through how you start up the engines and all the checks and the things you needed to do. And then I'd have you take it off and fly it around subsonically. Because remember I told you it was a 50s, 60s cockpit. So most of the guys were aware of the basic ADI, basic airspeed indicator, nothing fancy, nothing to do with the supersonic capabilities. I would then take you to lunch. And when lunch was over with, I'd bring you back to the simulator. And I said, okay, show me what you remember. It was a learning curve exercise. If you looked at me in the 40-mile stare, it was noted. If you basically got through most of the procedures, it was noted, and much to your advantage. So that basically, and then they had to wait for a class. We only trained 2 or 3 crews a year, and it took us a year to train you. And I had 100 hours in the simulator before I even started training. My navigator and I, we used to go down at night when the simulator wasn't being used. And because the simulator, if you did things wrong, would reward you negatively. And so we became accustomed. And then I probably had about 40 hours in the simulator when I had my first simulator check. And then the pilot comes out first, and he goes into the 2-seat trainer. And your first flight is your only flight you're going to have subsonically. So you take off. You now see what a takeoff looks like. you go up and you spend at least an hour behind a tanker and learn how to refuel. And one of the real tricks is the Strategic Air Command's policy is that if you got to the point where you didn't have enough power because the tanker can't go any faster and you're too heavy, you were supposed to disconnect, light an afterburner, then come back in. We said, that's BS. We want you to stabilize, warn the tanker, the boom operator, light the minimum burner, bring the other one back towards idle, and then lock it in so that you stay on the boom, because many times at the end of the air refueling, you needed to have a certain weight at a certain time so you could proceed, because it was a timed entry when you were going to do it. So once you'd done your refueling for an hour, then the instructor would take you back and introduce you to an instrument approach to start with, and you eventually end up flying overhead patterns and see what it looked like. When the nose comes up, because it comes up, you kind of lose, you can see the runway as you're coming in, but as the nose comes up, you're kind of looking down beside, and you can kind of see where the edge of the runway is and your altitude. From the back seat, we cheated as instructor pilots because we put in the ILS, because once that nose comes up, our seat, we couldn't see the runway. So we were kind of, okay, yeah, this is how you do it. You come down and you gently land. It normally worked. They didn't realize that we were kind of fooling them a little bit from our experience back there.
All right, we'll do a couple more questions from the audience. Thank you, Buzz, for sticking with us over on the East Coast. So first, a question from the gentleman who was part of the SR-71 program.
I just wanted to comment that Dave Campbell was the original designer of that inlet system from Caltech. And basically, Ben Rich was the principal, the guiding light for the propulsion group at the Skunk Works. So if you have any comments about Ben Rich, really a very remarkable person, extremely brilliant. So if you have any feedback on that, I think the folks here might like to hear about it. Thank you.
I really enjoyed working with Ben Rich. I worked with him a little bit in the SR program, but I kind of mentioned in passing, when I went to the Pentagon for over 2 years, I was in charge of all the black money for the Air Force. And in that black money was the 117. So I worked very closely with Ben, completing the development and the production of the 117s that were going to be based up in Tonopah. And I thoroughly enjoyed working with Ben. Those of you out there, he was just a wonderful individual, born in the Philippines. I can't remember what his father was doing. A great engineer, had a great sense of humor. I mean, he always had a joke. Sometimes they were a little risque. Some of the meetings at the Pentagon, they go, "Oh, okay, Ben, that's let's move on to business." But he just was a great guy. And when he went to write his book, he came up and spent half a day with me. And I just kidded Ben. I said, "I hope you're getting this cleared from the security people in the Pentagon, because I don't want to go to what's the name of the fort in Kansas? The prison, for those that leak classified information." Because he wanted to talk about the B-2. The Aurora program is what I named. And that was a cover story for the production money of the B-2. And we put it in such a way that it looked like it was a new reconnaissance system, the replacement for the SR-71, which fooled the media, particularly all the aviation writers. They were sure that we were creating a new, because we had $32 billion in the B-2 production line. And you try to hide $32 billion, you got to be creative. It was in a couple lines, but Aurora was the capstone that we were able to hide it from. But Ben was a great guy, and I was so sorry that he died so shortly after the book was published.
What was the maximum altitude attained by an SR-71?
After I left the program, we were doing more flights off the north coast of Russia. And, they tell you when you study, okay, the trope is minus 55 degrees C. Well, that's a nice average. I've seen it as warm as minus 40 degrees C, which means you're going to fly at a lower altitude and the airplane doesn't perform as well. I've also seen minus 90 degrees C. And when you're at minus 90 degrees C, the airplane flies higher, it wants to accelerate, And so the guys were getting into very cold air. And so I think SRs were probably up at 87, 88,000 feet. You let the airplane go to where it wanted to be. You know, if it, and we've typically, once we got up and we're at cruise setting, we pulled it back to minimum burner because it would hold the speed at minimum burner. There was no reason to keep the engines at the afterburner at that top. But then obviously, as you're going to change your altitude, you go into max burner for a little bit and then stabilize. But it's probably 88,000 feet. You know, the A-12s regularly flew at 90,000 feet, but they were 15,000 pounds lighter than we were. Same speed, just a lighter airplane.
All right, Buzz, we got one more question here for you, and then we'll let you go.
I actually have a couple of questions. You touched on the onboard computer systems a couple of times. Back in those days, there were no semiconductors. There were probably vacuum tubes. Vacuum tube electronic systems are characterized by high voltage and low reliability. So my question is, what issues did you have with the onboard computer systems? Were they triple redundant? The second question is, back in the day, the pilot's controls were typically connected to the control surfaces by physical cables. Did the SR-71 use physical cables with power assist, or were they actual servo systems?
Let's start with the computer. I don't know exactly. I can tell you that in all my flights in the SR, I only had one navigation failure. And that was taking off from Kadena. And we got, as we're passing through 10,000 feet, it says we're at the South Pole. So that flight was over with. It was a very reliable system for the most part, but I don't know on the inner workings. I just know what it did for us and that the star catalogs we carried, but the other part you're asking about, I'm just not sure. And I'm sure over time it was being updated by Nortronics, because Nortronics had the production license from the British company that created the sensor that we were using to lock on the stars. Okay, my senior moment. Your second question, if you could repeat it, cue me.
It had to do with the actual connections to the control surfaces.
Because the airplane grew, in the middle, in the back, there was a cable system for the airplane. And there was an expansion. It was really clever the way they'd done it. So as the airplane heats and grows, you know, Pete Law thought it was about 4 inches. Some people said it's 6 inches. It grew a certain amount. So you had to keep the tension that you needed on the cable to move. But by the same token, it had to be able to expand. The stick was very heavy. It was purposely heavy to prevent over-G'ing the airplane. It also, if you decided to pull the stick back too fast, the stick would shake and tell you, I don't like what you're doing. You're trying to load the airplane too fast. If you ignored the stick shaker, the stick had a pusher. And there was no human on the face of the earth that could hold that stick. It was slammed full forward with tremendous force. It was going to make sure that nose went forward. I believe the cables went back to the mixer in your pitch and roll. And some told us, I've seen pictures of it, it's about the size of a beach ball, that was developed by Bulova, that these cable inputs would average what you were asking and blend it into the elevons. How much pitch were you asking for and how much roll were you asking for? And it was blended all the way across. You know, later on, other systems adopted that same thing that Kelly's aerodynamics team had done for the flight controls on the SR. Because the space shuttle is the same thing. It's a blended system when it comes down. The pitch and the roll are blended together.
Okay.
Well, you can see I felt very privileged to have the opportunity to fly this airplane and to work with the people at the Skunk Works and many other Pratt Whitney and all the different agencies and everything that were part of our life. And when we flew the airplane, I mean, our whole focus, that was our job, to be as professional and fly the airplane the way It was intended so when people called upon us, if it was all possible, we'd be able to deliver the information they were looking for. It really changed your life. You know, there's not a lot of us, and I don't go around bragging. You know, I don't walk into groups and say, hey, I'm an SR guy. But you'd be surprised how often somebody goes, I think I've seen you on YouTube, because I've done a number of videos for the Smithsonian and Lockheed. Lockheed came to the Smithsonian and asked me if I would be the spokesman for their 100th anniversary, one of their videos they did for a few years ago. So it's been life-changing. It's been very enriching, and also for the family. We spent 150 average days overseas, because that's where most of our operational missions. The last year it was 210 for me, which was a little stressful. But we tried to do as much as we could with the family, even though we couldn't share with the family what we were doing. I mean, my wife knew I was in Okinawa or I was in England, but she really didn't have knowledge on what we were doing as far as operations in that. She did hear about the suit incident, because that kind of got out. And then it was in some books, so it's kind of hard to hide that. But and it opened doors for me later. I wouldn't have been the Blackworld programmer at the Pentagon, I think, if I hadn't had the SR background, because of the clearances I had in the SR program, which helped me understand how do you work a compartmented program, not just classified top secret, but compartmented, like the 117. You know, I mean, the big thing to take the 117 to President Reagan, because he was the authority for us to get it decompartmented, not declassified, because part of it was declassified, but many parts of the airplane remain classified. Matter of fact, many parts of the airplane are still classified today. You know, they got a couple of them up at Edwards, they're demodding, so they can go to museums, taking out all that stuff that still has military significance. And you probably don't know, I'm probably keeping you long, well, you're on the West Coast. The background of the 117. There was a Soviet professor, and right now I got a senior moment, but in 1964, 1965, he had worked up these equations that he felt if we did this with an airplane, we could make it very difficult for a radar to see it. It was a series of plates like you see on the 117. The Soviet Air Force said, we're not interested. That doesn't sound like anything we want to do. So he said, well, about a year later, because he was proud of what he had created, he went back to him and said, well, do you mind if I publish it? And they saw no reason to say no. So they said, yeah, go ahead and publish it. It's a useless paper. Well, the guy in charge of trying to make the U-2 stealthy, who was working with Ben Rich, came to Ben and said, I've got this article that I've had translated, and I think this guy's got an idea. Well, Ben went to Kelly, and Kelly said, Ben, that's the stupidest idea I've ever heard. He really got on Ben's case on it. But it went forward. DARPA thought there was enough meat to it. You have the AHABU program that comes along the 3/4 model. They look at it, it works. And you have basically a Russian professor lays the basic part that we learned to be able to do the 117 with the plating. And of course, in the end, Kelly was absolutely delighted and told Ben that. He said, you know, you were right, I was wrong. And those of you that were around Kelly, you didn't hear that often. I mean, he would admit it, but you had to have a pretty strong case. So Ben was exonerated in the end, saying you had the right idea. And so we built either 65 or 67 of those airplanes.
Well, Buzz, thank you so much tonight. I think this is been a fascinating program. I think this is one of the most engaged audiences I've seen ever, perhaps. So thank you very much for your time and for staying up late for us. And
I thoroughly enjoyed it. And you have a wonderful club. I can hear from the different experiences, the adventures I mean, that's what life's about. So anytime we get an opportunity. When I was a cadet, I did an internship at Edwards Air Force Base, and I'm not a shy guy. So I convinced Pete Knight to let me fly in the back seat of a F-104 while we flew chase on an X-15 that Bob Rushworth was flying. So you can kind of see I always kind of like to venture out and try something new. And I was never shy about asking that. So
if you
it
find
was
yourself,
it was a pleasure being with you tonight, and I wish you all health and good luck as you go forward.
well, thank you. And certainly, if you're ever out in the area, you have an open invitation to come join us for a night.
I just may take you up on that when I come out to the West Coast sometime.
Excellent. Thank you. Well, thank you, everyone, for tuning in tonight. If you like what you saw, please like the video and subscribe to our channel. And tune in the future for other great programs. Have a great night.